Hi everyone, in this video for one-dimensional kinematics, we're going to do a stone thrown upwards. Okay, so a stone is thrown vertically upward with a speed of 11.5 meters per second from the edge of a cliff 63 meters high. A. How much later does it reach the bottom of the cliff? B. What is its speed just before hitting? And C. What total distance did it travel? Okay, so logically we're going to start with A, and before we start anything, you draw a picture. So hopefully you saw that coming. Okay, it's a cliff, it's really straightforward. You don't want to make it too complicated. Okay, so my cliffs generally are very artistic. They look like that. They look like the setup for Hangman, but backwards. Okay, I'm going to define my positive direction. Now in this case, I'm going to do up. Like I mentioned in my previous video, I'll be trying to mix it up just now in the beginning so you guys can get used to, being able to do different points of view, because it really doesn't matter which one's positive. True, one direction will make it a bit easier, but for the most part, just keep your numbers consistent, your directions consistent, everything will work out. Okay, so I've got a little person there, and they're throwing, well, a stone straight up. So it's going to go up, and then it's going to turn, and it's going to fall back down to the ground, right? Now, as it falls, it's accelerating, and we know it's accelerating due to gravity. So we're going to say that the acceleration is negative g, or negative 9.8 meters per second squared. Okay, we know that the stone is thrown vertically upward at 11.5 meters per second. That's at that point right there. Okay, so v naught equals 11.5 meters per second. Okay, now this is the height of the cliff. Now what you have to understand here is that true, the stone is going up, then it's coming back down. It travels a bigger distance than the height of the cliff. But what you have to understand that relatively speaking, assuming that, the cliff is a lot higher than the person's arm based on the cliff, the displacement of the stone, so its final position minus its initial position, is the height of the cliff, 63 meters, okay? So that's why I'm going to say that delta D, the displacement, equals minus 63.0 meters, okay? Be really careful with that, because if you put positive, it's not getting displaced upwards, it's getting displaced downwards, okay? Now, focusing on part A, it's asking us how much later does it reach the bottom of the cliff. It's pretty much asking us to find the time, okay? So that's going to be A, okay? Part B says, what is its speed just before hitting? So that's here. That's going to be V. And what total distance did it travel? Well, we'll get to that in a few moments. Okay, so let's start off with A. Okay, so how much later does it hit the bottom of the cliff? So we're going to start with the fact that we know what its displacement is. We know its initial speed. We know its acceleration. We have to find the time. Okay, so let's go ahead and we're going to use this kinematics equation because it is suited the best. Okay, delta D equals V naught T plus 1/2 acceleration times squared. Okay, so my delta D is minus 63.0 meters. Okay, my V naught is 11.5 meters per second times T plus 1/2 acceleration. Here in this case, it's going to be negative 9.8. Okay, so negative 9.8 meters per second squared times t squared. I really hope you guys are seeing where this is going. If you watched my previous video, stone falling, okay, you already know where I'm going with this, okay? And if you didn't, what you need to recognize in this problem is that you've got a term in front of a t squared, a term in front of a t, and then a term that has no t, okay? Usually when we plug in our numbers and we're missing one variable, we're left with one of the variables by itself. But in this case, we've got a t squared and a t. Okay, so we can't just isolate, get everything on one side and solve for t. We need a little bit more creative means of solving it. Okay, so we're going to have to use the quadratic formula. So, we're going to have to get this in the form ax squared plus bx plus c equals 0. Okay, so hopefully you remember the quadratic formula. I'm not going to sing it again. I sang it in the last video, so if you really need to watch that, I don't know why you would, but if you really want to watch that, you can go back to my stone falling video and it's there. Okay, but nonetheless, In this case, we're not dealing with x's, we're dealing with t's. So here is the quadratic formula applicable to this problem. So t equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so then you might be wondering, well, what's a, what's b, what's c? Okay, so a, b, and c are very specific. You cannot just plug in one for each. It has to be specific ones. Okay, so based on this formula, a is the number that's in front of the variable that's squared. So that's this right here. 1/2 times negative 9.8. Okay, b is the number in front of the variable with an exponent 1. That's this, t to the 1. So b is 11.5. And c is the number where it has to be on the same side as these variables, and there's no other number attached to it. So you know what I'm going to do? I'm going to take this and I'm just going to rewrite it down here in the correct form, just so you guys can see. So I'm going to keep 0 on the left, which means I'm going to take that minus 63.0 and bring it to the right side of the formula. So I can get it in this form. Okay, so 0 equals, the negative 9.8 times 1/2 is going to be negative 4.9. Okay, I'm not going to write the units this time, but you get the idea. Minus 4.9 t squared plus 11.5 t plus 63, oh, pardon me, that shouldn't be a t. Okay, plus 63. All right, so we've got our A. A is negative 4.9, B is 11.5, C is 63.0. Okay, so obviously you plug in your numbers. Okay, so why don't we just go ahead and do that? I'll do the first step for you guys, and then the rest, honestly, is just entering it in your calculator. Minus 11.5 plus or minus, okay, it's the plus or minus that gives you the two roots, that gives you the two possible answers. 11.5 squared minus 4 times negative 4.9 times 63. Okay. Oh, divided by 2 times negative 4.9. Okay, so you get two answers, two roots, as it is with any quadratic formula. T1 equals 4.95 seconds. T2 equals negative 2.599 seconds. Okay, so as with any quadratic formula, sometimes both answers make sense. In most cases, one answer makes sense. You have to weed out the one that doesn't. Okay, so because our variable that we solved for here is time, assuming you didn't invent a time machine last weekend, okay, this is going to be the incorrect value. We're going to negate it. We're going to ignore it because we're going to assume that there's no negative time. Generally speaking, people want to see why you crossed it out, so always just write a little short blurb. Don't just cross it out because it'll look like you just did process of elimination or eeny, meeny, miny, mo. Okay? Always just write a small little thing there to save your butt. Okay? So this is our time. Okay, so t equals 4.95 seconds. That's how much later it reaches the bottom of the cliff. Okay, so there you go. That's the answer for part A. Okay, now for part B. Part B, let's remember what it was. Part B asks, what is its speed just before hitting? Okay, so based on the picture, okay, so we found how long it's in the air. Okay, so actually, why don't I go ahead and write that in? 4.95 seconds. Now we got to find the speed at which it hits, okay? So the reason they ask you the question in this order, ABC, is because to do B, you actually need the answer from A. Okay, so, all right, so let's do that right here, okay? So for part B, okay, we're gonna look for speed just before hitting, but we're gonna do this in a really unique way. Now that we know time, we already knew the acceleration, right? The acceleration is gravity, negative 9.8 meters per second squared. Okay, I know the initial speed that it's launched at. Final speed, well, I can get that too, right? That's what I'm looking for. What is its speed just before hitting? So let's solve for that. Okay, based on the definition of acceleration, that it's equal to the change in speed over time, I'm looking for v. So before I even do anything, let me rewrite the delta v more clearly. Okay, the change in speed is the final speed v minus the initial speed v naught. And lo and behold, that's what I need to find, the v. Okay, So let's finish writing this over t equals a. Okay, we're looking for v, so let's isolate it. So the first thing you do is multiply both sides by t because it's dividing into the entire numerator. Okay, so multiply both sides by t. Then after, to that entire expression on your left, you're going to add v naught. Okay, so first step is at equals v minus v naught. And then you add the v naught over and you end up with v equals at plus v naught. Okay, so let's start plugging in our values. Okay, so a is negative 9.8 meters per second squared. The time that it's in the air, we just determined it's 4.95 seconds. We need this total time because we want the speed after this time, so it has to be accurate. Plus the initial, which is 11.5 meters per second. Okay, when you put that on your calculator, you're going to get negative 37.01 meters per second. Now hold on a second. Why am I getting negative speed? Okay, remember the question? We defined up to be positive. When it's going down, that means it's going in the opposite of the positively defined direction. So we should get a negative answer. If you don't, then you know you did something wrong. And that's what I mean by just stay consistent, okay? So minus 37.01, based on the original question, the most certain answer we have, or the most certain information we're given, all has 3 sig figs. So we're going to write this with 3 sig figs. So v equals negative 37.0 meters per second. And there you go. That's the answer for part B. What is its speed just before hitting? Wow, this is really long, huh? All right. Finally, part C. So let's just remind ourselves what part C is. Okay. What total distance did it travel? Okay, so this one actually requires a bit of understanding, just like everything actually, but this one more so. Okay, so we actually know part of the distance it travels, right? It's 63 meters. We know that from here to here, it's traveling 63 meters. All we really need to find is this distance right here, right? From the hand to the top. Once you find that distance, you just double it and add the height of the cliff, and you've got the total distance that it travels. Okay, so hopefully that makes sense. You find the height from the cliff to the top, double it because it appears twice, and then you add the height of the cliff. So then, we know the height of the cliff. All that's left for us to do is find this height right here. Okay, so again, this is why a picture speaks 1,000 words. Okay, and in physics, it helps you 1,000 different mathematical ways. We know the initial speed, that's right here. Okay, that's at the start where he throws the ball. At the very top of the ball's path, think about what the speed is at that point, okay? The ball's going up and up and up and up, and it's slowing down due to the acceleration due to gravity. And when you throw a ball up, it slows down, slows down, slows down, becomes 0, then it turns around, speeds up, speeds up, speeds up. So at that point right there, the speed is 0 meters per second. Okay, so now think about that. You've got an initial speed of 11.5, a final speed of 0, an acceleration of negative 9.8. Can we find the distance? Yep, you betcha. Okay, so we're going to go ahead and do part C now. Okay, so this is how we're going to find the distance. Super, super straightforward. This is the kinematics formula we're going to use. 2AD equals V2 squared minus V1 squared. Okay, at this point, I know which D I'm dealing with. That D is this distance right here. It's the distance to get to the top, from the person's hand to the top of the path. Okay, so 2AD equals V2 squared minus V1 squared, which in this case, we're actually calling it, so pardon me, we're calling it V and V initial. Okay, so different people have different naming conventions, but here, let's stick with the one we have. And we're looking for D. So to get D by itself, you have to divide both sides by 2A. So V squared minus V naught squared divided by 2A. Okay, plug in your values. We just stated that V is 0. So because that's 0, this whole thing goes away. And we're left with negative V naught squared over 2A. Okay, you're probably like, just plug it in already, but you know what? as you do more complex problems, it's actually beneficial to simplify the problem first, the equation, and then plug it in. It actually will save you time later on. So just get used to doing it now. Okay, so without further ado, plug it in. Minus 11.5 meters per second, that gets squared, don't forget, divided by 2 times the negative 9.8 meters per second squared. Okay, plug that in, enter it in your calculator, and you're going to get the wonderful number of, let's see, D equals 6.75 meters. Okay, so now just to recap, that's your cliff. Okay, the ball's going up, it's coming down. Okay, that distance is the height of the cliff, 63 meters. Okay, 63.0 to be exact. Okay, what we just found was this distance, so that's 6.75 meters. Clearly the image is not to scale, but that's okay. Okay, just to give you an idea, if that's 6.75 meters, that means this is 6.75 meters due to the symmetry. Okay, so the total distance the stone travels is 6.75 plus 6.75 plus 63. Okay, and that's what we're going to do for our final step. So the total distance for the stone, okay, 6.75 meters plus 6.75 meters plus 63 meters. Now you're probably wondering, why did she write it like that? I just did that to make it hopefully a bit more clear that this is the distance up and this is the distance down. Okay, so distance down, distance up. Okay, and when you add those two together, you're gonna get 76.5 meters, and therein is your answer to part C. What total distance did it travel? Wow, that was a long problem, 3 pages. So guys, that's it for this video. If you could hit that like button, that would be greatly appreciated. If you want to subscribe to my channel and stay tuned for solutions to more and more amazing AP questions. Stay tuned and definitely hit that subscribe button. If you are already subscribed, make sure you hit that little bell notification next to the subscribe button so you can be notified anytime I upload a new video. Okay? Overall, that's it, guys. I hope you have a great day, night, morning, whatever time zone you're in, and I will talk to you guys later. All right, cheers.